Forgot to be recording. So the back of your spirals, you're doing problems 1 and 2. Can you do the inverse by switching x and y, solving for y? In case you're stuck, remember, another way of writing this is y equals 3x minus 1. Now switch x and y, solve for y. If you didn't know how to start it. F of x means y, right? Switch x and y. Switch places and then solve for y.
6 over 2. You have to multiply the entire Definitely, that's what you get.
I just felt like, no, because, I reversed the division. So I took that, put it on the other side, and I multiplied that. 3 minus y. Oh shoot, I screwed
But
up.
now I have yx.
No, I didn't.
See, I'm not doing this right. Negative yx is equal to 2 plus y over 3. And now I guess I divide by x. So now I get x negative y is equal to 2 plus y over 3x squared. I think I did it wrong. Bail me out, please. Oh yeah, that's what I have. But there's more on the other hand. Yes, Caleb. I have x plus 1 over 3, which is 1/3 x plus 1. Oh.
Does the first one make sense?
No.
Absolutely.
Okay, if it doesn't, where'd we go wrong? First of all, does it make sense f of x is y? Okay.
Oh,
So then we take the variables and we literally switch them. Right? Then we go ahead and do the math, meaning get y by itself. Add the 1, then we divide it by the 3. This is 1/4. We can actually technically divide by 3. We can say times 1/3, just another way of writing it, hence why I put the or. But why do I not leave this notation the way it is? Who's y? This one. Who's this? His inverse. So we go one extra step, and that's why I said yesterday, make y into f inverse of x, because otherwise it doesn't make sense. I can't have this y stay when y is really someone else entirely. So then I start naming it. This is f, and this is his inverse, which either one is correct. Huh? What did it? Okay, give you a second. All right, go ahead. If you weren't able or if you got stuck, go ahead and try the second one. Sad thing is, I think the second one's a little bit harder.
yes.
My hint. Wait.
What's the hint?
My hint. After you switch x with y, or make the x's into y's and the y into an x, multiply by 3 minus y. Multiply. Distribute. Get all the y's on one side. You might still get stuck, but multiply, distribute, get all the y terms on one side. Yeah.
Oh, I get it. Oh, never mind. So now I just. I don't know how I did that. But doesn't that get 1 over x though?
It's supposed to be x over 2.
actually an SAT problem that's kind of similar.
Oh.
It's the one on the board, or an SAT-ish problem is the one on the board. They like to give you that one because you're like, I can't do it. The same process that that SAT problem needs is what this problem needs. So I'm not saying it's easy. I'm not saying it's easy. But how does this one work? What was my hint? No, it's a little different. We'll come back. Multiply. That's what my hint was, right? Have to multiply by the whole denominator. That way it cancels. What I do to one side, I do to the other. What was my next hint? Multiply and then distribute. Don't worry. Okay. All right. Okay. In this problem, why is this better?
Because now you can just do some adding and stuff.
Yeah, but hold on. Go ahead. Oh, I'm saying there's a similar type of problem. So it's not solving for an inverse. It's not this one. But there's a similar type of problem that just says solve for x. SAT, math, people love to do this because then you get stuck here. You don't think about multiplying. So we're going to solve this, then come back and see how it plays. Wait, what do you do? Get the x terms on one side, right? So we end up having, hopefully, can we see if we subtract the 2 and add the 5x? Is this okay? Add the 5x over, so it's going to be 5x plus x. Subtract the 2, so 15 minus 2. And we end up with 13 equals 6x. X is equal to 13, 6. Now this is technically still hard, but easier than the one on the board. Why? There's a number. And there was only one variable, right? There was no y. So this one, okay, it's harder, but it's not impossible. Y equals, you're not allowed to say it's impossible just because you might not know how to solve it. Just say it's hard and that you need help. Okay, inverse. Switch the. Why is it similar to the problem on the board? What were we solving for over there? X in two different places of a fraction. What are we solving for here? In two different places of a fraction. That's the similarity. I did tell you to go ahead and multiply both sides by 3 minus y. That's the only way to go. Okay. I said multiply, then I said distribute. Don't say you can't if you don't know how. Just say it's hard and that you need help, right? What did I do when I tried to get x alone? Moved it with the other x's. Now what am I solving for in this one? Y's. So I'm going to move the y terms together and the non-y terms together. Now, I know, I did some algebra fast. I subtracted the 2 over, so 3x minus 2, and I added the xy over. Are we okay with the math? Because some of you are still looking at that and being like, there's no way to do it. How do you get y alone? Oh my goodness, he factors. He's in both. He's by himself now. Divide the y from the x. X is alone. Divide the y from the y. I need a 1 as a placeholder, so if I distribute, I get back to where I was. This is a common. Some of you guys forget the plus 1.
My gosh, that is too much. My brain hurts.
I'm not done yet, though. I have one more thing to do. What's that one more thing? Change the y. He's not allowed to stay a y because that was the original. Change him to f inverse. Now, question. First of all, how many people actually got all the way there? How many people got part way and got stuck with the whole Y thing in the bottom? Okay, next. Now, better question. How many people are like, I followed that and I think I kind of know what you did? That's it? Oh no. Wait a minute. One more time. One more time. How many people are like, I followed you and I think I kind of got what you did? Okay. This just means we need a little more practice. Now, those of you that are not ever raising your hand for anything, I have no idea how you're doing because you're not communicating. So communicate, okay? Last question. How many of you guys are like, no clue? No clue? No clues. All right. I would love to sit down and tutor you guys on every single homework assignment and know exactly how you are. That was my heart. I was a tutor before I was a teacher, but I can't. I have 120 kids. So I need you to help me help you. Yeah? Yeah, don't. But anyway, in this context, I need you guys to communicate with me. So please, this is my plea. Answer the questions as honestly as you can. If it's actually you, just give a quick raise. It doesn't have to be a this. It can be like a, and I can actually see a hand moving, I promise. Like I'm trained enough to know kind of where a hand, yeah, exactly. See? I saw that hand raise. Perfect. And your group probably doesn't even see if you're doing like this. You can just be like, I don't know, shooting a fly. Doesn't matter. So no need for embarrassment. Just kind of tell me where you are. Cool? Cool? Can I have everyone just as an assent, meaning you are agreeing. Consent? Yeah, wrong way. Assent? Consenting to what I just said. Do a little baby raise hand to be like, okay, I'll try to answer your questions from here on out. Come on. Please, thank you. Okay. All right, are we done with this whole no one ever raising their hands for anything and then I'm totally lost? Are we done with that? Okay. That's cute. Well, probably not, but at least we've talked about it. We've gotten the issue out there and we'll work on it. So, in your notes, we've done one straightforward one hard one. Totally, I admit it was hard. In the back of our spiral. So let's go to our notes and let's get a good example in. There are two parts to this example. Part number 1 says find the inverse of. Part number 2 says verify. So start with part number 1. We just practiced it 2 different times in the back of our notes. One was straightforward, one was hard. Yes, the whole one-on-one thing, like me actually trying to work and figure out your weaknesses and help you through. That's what can happen during lunch or after school if you actually come in. For free. Yeah. Free for you and free for me. It's kind of sad it's free for me, but it's nice it's free for you. Okay, here we go.
It's free, I have to get it.
See, gotta take advantage of that deal. There might just be a little bit of a line, but it hasn't been too bad yet this year.
It's not cool, it's not worth me.
Just come back. Find the inverse. You have a function. We're doing an example. This one is easier than either of the ones in the spiral. And as you guys are doing that, let me change homework number 9, due Friday, to what it is, due tomorrow. Because tomorrow is Friday. Yeah.
Yeah, she said it 28 times.
That's a little dramatic. Okay, so you guys look at the backboard real quick. What else am I putting up that I haven't specifically said? Okay. Listen. Quest corrections were technically supposed to be due tomorrow, but we have a lot in section 1.9. I'm going to make it due on Monday.
Yay.
Now, how many days have you had to work on this?
46.
We're traumatized again, but it's not a few. Why am I bringing up quest corrections with my whole, like, I have the heart of a tutor trying to actually help you one-on-one as much as I can? Why am I bringing that up right now?
Because you have to.
If you're stuck on your corrections, come and let me help. Sound good? Okay, come today, come tomorrow. I'll be in here during lunch, I'll be in here after school. And if I'm not in here, come to the senior patio during lunch, but otherwise I'll be late.
So is the number that was at the top of our test what we got out of 50?
Yes.
Yeah, 2%.
I didn't realize until I was passing out the TA didn't put over 50 for all of them. It wasn't in percent. It was a half test, which I told you before, but a lot of you probably were like, out of 50. Out of 50. All right, come back. Thank you, thank you. Very first thing we were supposed to do is find the inverse. Who is the function that we're finding the inverse of? That's it. That was it.
Yeah.
So if I want to find the inverse of y equals 4x, the very first thing I need to do is switch. That's what I was listening for. A couple of you guys got it. Switch the x and the y. Yeah? And then solve for y. Yeah, this one's a good one, right? Do some hard ones first, then good one later. Y is equal to x over 4. I'm not done yet. Change the y to an f inverse. Now, is there actually another way of writing x over 4? Mm-hmm. We kind of did it in the example in our spiral. What's another way of writing x over 4? And why is that helpful? Some of you, if you saw x over 4, would not realize it's a line with a slope of 1/4. Right? Your brain clicks with this one hopefully more than it clicks with that one. Just trying to help us out. The more we can help our brains out so it doesn't have to do as much like crazy processing, probably the happier it'll be. That's the inverse. But there was a second direction. I just didn't really give you direction as to how to do it. I did yesterday. But when it says verify, I'm checking, right? And how do I check? I have to make sure, plug in what though? I have to make sure that this thing actually meets the qualifications for being an inverse. Meaning, if I take a composition of one inside the other, everything should go away, all the operations should go away except for x. So when you said plug in, you were right. But plug in what? F of, and who's G? My hypothesis for the inverse. So I plug in, who is F inverse? X over 4, or 1/4 x. And where am I plugging it into? 4 times. Just like f of x states. So if I plug in x over 4, or 1/4 x, what happens? Oh my goodness, everything goes away but x. Is that a good sign? That's a great sign. And technically, if I was to go the other direction, f inverse of f of x, or g of f of x, I would be plugging f of x into the x of the inverse. Who is f of x? 4x. Oh my goodness, what happens? That's great. Got it. Good? Now, were we pretty sure that we had gotten this right from the get-go?
Yes.
Yeah. But maybe a couple of the others. Would it make sense that maybe there'd be an addition, multiplication, subtraction, something mistake that might make you a little bit off? And how could you find that? This wouldn't work. Okay? Let's keep going. Keep going! Yes, there's more. Oh, come on. I'm not done with class. You guys. Remember yesterday, though, Tyler, you were actually the one that said it. You're like, isn't it a reflection across the... What did you say?
Identity function.
Across the identity function, who is the y equals x line. All right, here we go. We have worked thus far with inverses algebraically. Okay, why am I saying algebraically? Pourquoi?
Because we only worked with numbers and equations.
We worked with equations. We worked with equations of originals, and we worked with equations of inverses, or find the equations. Switching x and y, that's all algebraic. We're working with the equation. But now we're going to be talking just a little bit about the graphs. And some of homework, literally, it's going to have you work with the inverses algebraically, actually find the inverse, and then graph it to check. Graphing it how? How? In your calculator. Graphing it y. To try to further cement the idea or the truth that a function, if you guys notice, f of x, here's the original function, and his inverse, f inverse of x, are reflections of each other across the y equals x line. It's not going to be reflections across the x-axis or the y-axis, but reflections across the y equals x line. So if you were to find an inverse, think that you were right. Go to your graphing calculator. And you don't see the symmetry, you don't see this reflection across up here in the first quadrant and then down there in the third quadrant, you don't see a reflection across, something went wrong. Another way of checking, but that's not all. Another way of checking, but that's not all. One more quick thing I want to draw your attention to before we keep working graphically with inverses. What do you guys notice about this? Not opposite, but you have the idea. They're switched, right? They're backwards. Because how do we solve for inverses? Oh, that actually kind of makes sense, right? If we switch the x's and y's, then what was an x is now a y. What was a y is now an x. That's how all inverses work. We'll get back to that in a bit. So we're not doing like what we did with transformations. We're not just changing x's or just changing y's and like reflecting them or shifting them. We're literally just switching them. And hence why it has this symmetry across. Most of us should have this sketch pretty close to it, yeah? Okay, let's keep going. Now, wait. You don't have to write it down. You don't have to write it down. But if we had two different functions, just further proof, if we had two different functions, f of x is and f inverse is, could you guys have found this one if you needed to? Yeah. If we had two, and if they said graph it and check it, can you guys tell, does that have y equals x symmetry? What else could you graph to help yourselves with the checking? So when they tell you to graph and check, go ahead and graph the y equals x line itself. And if what's on one side is on the other, what's on the other is on the one side, you're good. It has that symmetry. You're just eyeballing it. But do you see now how it has y equals x symmetry? What's on one side is on the other and vice versa. Okay? So I just wanted to make sure when you graph, there's one other thing you can do, but first of all, graph the y equals x, graph the line of symmetry. And then there is a zoom that kind of makes everything, because in your calculator, remember it's a rectangular screen, but with square dimensions. What's that zoom that evens everything out and doesn't distort it? Okay, that's another good thing maybe to use, is to use your zoom square, because that makes, remember, all the units, all the tick marks, equidistant, because if you can tell, this isn't equidistant right now, right? This is like the normal 10 by 10. So zoom square would help this picture be a little bit clearer, and y equals x. Let's keep going. Numerically. We'll do it graphically, or an example with graphs in just a second. But first of all, to help us numerically, let's go ahead and talk about what I just tried to draw out from that picture 2 slides ago. That first page we were talking about inverses. F of g of x equals x, g of f of x equals x. Switch to x and y, solve for y's. There was a little note down at the bottom that said, since we switched the x and y, the domain of one is the range of the other. And the range of one is the domain of the other. So if the domains and ranges switch, that's the big picture of all the x's and all the y's switch, then for each individual pair, it is going to switch as well. So if I was, for instance, to go ahead and quickly cover all of these, which you guys have already seen it, and that's totally fine. But if I was to go ahead and cover all of those, and if I was to say, hey, these points are on that function, so give me some points on this function. How could you get them? Yeah. So then if this point's on the original, then -5, -1 is on the inverse, right? 0, 3 is on the original, then -3, 0, and et cetera, et cetera, et cetera. You can find the points of the inverse by just switching the points of the original. Now, why don't we just do that instead of the whole switch x and y, solve for y? It takes a lot of time. Yeah, you have to choose like representative ones, and that can be hard to know which points to choose. So that's not how we're going to be solving for inverses, but that is something that I bet a couple homework problems at least are going to have you kind of test out. Do you realize you literally just have to switch the x's and the y's? Okay. Before we do this, let me pause for just a second, and let's practice how to graph an inverse. Given some of us are super visual, some of us are not as much. So for some of us, this following activity is going to be pretty easy, but for others, it's actually going to be a little rough. So what if I don't give you the equation for f? What if I give you the graph for f? And I ask you to reflect. It's a little rough. Maybe find the equation, but it depends on the graph.
Do you mean give the graph, not given the graph?
Well, I'm going to give the graph, but you guys are going to be given the graph.
Oh, give it. Okay.
Is that cool? Okay. English. It's killer. What if I was to give something like -3, 0. Let's go with 0, 0. Let's go with -1, -2. If I was to call this f of x. Some of you are like, it's a parabola. I can find an equation of that. And that's awesome if you can. Very proud. Shouldn't be proud necessarily, though, because it's definitely from a past math teacher that you can do that. However, how would you, not given the equation, and without making an equation, because that's not the purpose of this section. The purpose isn't to figure out from the vertex what is the equation of the parabola. That's coming, but it's not technically right now. It's more in chapter 2. How could we reflect this? Caleb?
You take the points and then like reflect them.
Okay, so you could.
Basically.
Now, depending on how precise the graph is. My graph is really precise, and then I gave you actual points. Depending on how precise the graph is, you might be able to go ahead and identify, hey, I have -3, 0. I have -1, -2, and I have 0, 0. Flip them, right? We just talked about the point switch, so switch the points. And if you switch the points, what would you get? 0, -3. Oh, that'd be down here? Yeah. What else would you get? -2, -1. And 0, 0. And some of you are like, I don't, right? Because flip 0, 0. Flip 1, -2, that's -2, -1. Some of you visually are like, oh, I see it. And some of you are like, So what else could we graph? Couldn't we also graph the y equals x line? I'm just doing 1, 1, 2, 2, 3, 3. Pretend that's straight. That's rough. Now let's see. Instead of going this way, take one piece at a time. Instead of going this way, where's it going to go? This way. Oh, I meant for that to be blue. Struggle. Undo. Color coding fail. Okay. Do you see how I just flipped one part? Oh, it's not bad. Flip another part. Oh, okay, so instead of going this way, where's it going to go? Yeah. Oh, hey, I have a point over there. Right? And then what's the last piece? I know, but it goes on forever, so it's okay. It's fine. There. Got that right? Instead of going this way, where are we going to go? Half. Away from the y is going to be away from the x. Got it. Does that make sense? Now, do you see how it can be visually kind of hard, though? Like, how do I... But if you take it piece by piece by piece, it's not too bad. And if you can find a few points and switch, then it's going to help a little bit as well. Is that okay? All right. Let's go back to, okay, we have one more page to cover. And it has to do with basically an adjective of functions, a special characteristic of functions that has to do with the inverses. Pull it down a little bit. Do you guys ever wonder why things are on the ceiling? It's because my projector, I got a new one. But he's not positioned in a way to fit on my smartboard. Believe me, I tried everything. So this needs to get moved, and that's not my ability. That's not what I'm supposed to do. Ricky.
Why can't you push the smartboard back?
Guess what happens when you push it back? Does anybody know how light works?
No.
And reflection?
Oh,
The whole thing gets bigger.
Bigger.
Okay, so the plan move it closer.
Think.
Because it goes
If you put your hand in front of the projection, how big is the projection?
Oh.
And then you go back, what happens?
Why don't you put it like right in the middle of the class?
I could put my smartboard over here, but where's my projection?
Oh, but actually, like,
I'm just saying that I can't get facilities like I even touch that. Come back.
Why don't you move this?
There's a request. If I move it up, sadly, it does get smaller, but it goes up. Caleb, so it's even worse. Anyway, but thank you. These are all things, yeah, I definitely was like, yeah, this will fix it now. Okay, one-to-one. It's a special adjective. It's a special characteristic. One-to-one is also called invertible. A special adjective, a special characteristic describing functions whose inverses are also functions. Wait, that's a problem? Why is that a problem? Isn't that true for anything? Was the first one a function? Yes. But was his reflection a function? So guess what? This little dude is not one-to-one. Look, we can shortcut one-to-one and use numbers. He's not one-to-one. His reflection, his inverse, is not a function. That's what's going on. Not every function has an inverse or a reflection that is also a function. So there's a special adjective to describe those who do or who are. Now, if the inverse has to be a function, then the inverse has to pass what test? Yeah, vertical line test. We've learned that one. But for the inverse to pass a vertical line test, what must the original pass? The horizontal line test. For the inverse to pass a vertical line test, the original must pass the horizontal line test. X and Y switch. So instead of having a vertical line test for the inverse, we can actually look at the original before any reflections have taken place, before
so both of them
we've switched X and Y solved for Y.
both of them need to pass both tests.
In essence, yes.
So the first one can't be a function?
The first one has to be a function first. So it has to pass the vertical line test first. But then it also has to pass the horizontal line test. It's an additional qualification. So remember, one-to-one functions are functions first, with the added characteristic of passing, just like we do with vertical line test, the HLT, the horizontal line test. And it works the exact same. Yeah, parabolas will always fail. Y equals X will pass. So each Y value is paired with one and only one X value, so that when we switch it, it's still okay. So what would be an example of something that does pass the horizontal line test? We could do something like square root of X. We do something like square root of X. So if we were just to take square root of X, and if we were to reflect him, we can say he is one-to-one. He is invertible. Why? Because if we reflect him, I was doing reflections with blue. Square root of x passes. Now this looks like it gets vertical. It's actually just kind of heading to the left really slowly. It passes the vertical line test. It passes the horizontal line test, which means its inverse will also be a function. Fn for function. If an original is 1 to 1, that means his inverse will be a function. Now there's some funny stuff that goes on with this in a sense of if you were to solve for the inverse of y equals square root of x, it's actually kind of funny because you get x squared and you're like, wait, but x squared, that doesn't work. So we have to actually add in or remind ourselves of something like when we do it algebraically. If we look at this function question, what is his implicit or implied domain? Everything greater than or equal to 0. Remember, it hits at 0, 0. Everything greater than or equal to 0. So when we find the inverse, this domain gets translated over to the inverse. If x could only be greater than or equal to 0 in this one, if x had to be greater than or equal to 0 in this one, question, what's the restriction for this one? Why am I writing range? And why am I writing y's? X's of ones are the y's of the other. Now some of you are like, well, x is greater than or equal to 0 too. That's true. Because technically for this one, y is greater than or equal to 0 as well. But I'm just trying to show you, if you have a restriction in one function, when you take the inverse, it actually needs to follow so that we don't lose this one-to-one relationship. But that's something you might see a little bit in homework. I don't know. If it does show up, it'll be like in 1 or 2 problems. We can talk about questions tomorrow. In a sense of this whole weird restricted thing and how it follows. I'll put little parentheses around him just so it doesn't look to be a huge topic. But what does it mean for a function to be 1 to 1? He passes the vertical line test. He's a function. But he also passes the horizontal line test, which means his inverse will be a function. What else do we have? Pencils down. Don't worry about writing. Just eyes up here. Which ones are easy to figure out whether or not they are 1 to 1? Oh, the table's the easy one? I thought he was the hard one.
Oh, really?
I don't know. Right? Does he pass the horizontal line test? Yes. So is he 1 to 1? Yes. He's 1 to 1 or he's invertible. And then, does he pass the So obviously not. He's not 1 to 1. I don't know. I think those are the easy ones. Table, you're like, oh, stink. What? What am I supposed to do? Well, A, you can cheat and say, he's a parabola, he fails. Okay, but what if you didn't know that? Each x goes with one and only one y, but to be invertible, each y also needs to go with one and only one x. Struggle, does he pass?
No.
I don't think it's bad, but I think it's a little harder if you don't know the x squared part. I think it's a little bit harder. So since we have 2, yeah, that doesn't work, and that one doesn't work as well. Are we done? Do we have more? Oh, it's homework help. And more homework help. And then done. Now hold on. Let's go back to the first homework help. Have we done things like this today? Oh, remember him in the back of the spiral? We had x's in 2 places and we went and we solved? Okay, then maybe you're okay with this homework help. Or you can look in the back of your spiral and you can be okay maybe, or at least work a little harder. You have an idea of what to do. Over here, maybe he's not too bad. Let's go ahead and start with him in a couple minutes. Let's not look at number 2. Let's look at number 1. They're examples. You can do them in your notes if you want. Yeah. Spiral is really just like the beginning of class, group exploration, that sort of stuff. And homework, obviously. How do we solve for the inverse? Okay, so the x goes over here. Can we do this now without me writing y equals? Is that okay? Switch the x with the y. What are we doing? We're solving for the inverse. What's our goal? What's our job? What's our objective? Get or y? By, and Ricky, you're right, I would square root, right? But when we square root, can't a positive squared be, and can't a negative squared be the exact same thing? If we put in a square root, we have to add a plus or minus. The square root isn't there before. And since the square root isn't there before, since we're putting it in, it's not already assigned to be positive or negative. So we have to put both signs and say it could have been a positive squared or a negative squared. They end up with the same answer. Now how would I finish solving? Add the 2. I'm going to put the 2 in front. Is that okay? Makes a little more sense. I'm done! No, I'm not. What'd you forget? Change the thing. Change the notation. Yes. Now, there was a question that we kind of actually cheated and skipped. We skipped letter A. But wait, what does letter A ask? Could you think of it's a parabola? It's not 1-to-1? That's one way. The other way is when you solve, the plus or minus shows me, you need 2 functions to make one inverse. That's going to fail too. Does that make sense? Number 2, I think you guys will be fine on, and this homework help. This is the weird domainy thing. So come in tomorrow if you have any questions on domain and homework, and we'll go over them for sure. But what's due tomorrow? Homework number 9. What's on the back burner that you should be working on and coming in if you have questions on? Correct? Bye, guys. That was one of my favorites.
It's a yes or no question.
Why can't you throw it away? That's the real.
Yeah, Tyler.
I can.